Dear students, so far we have seen the process of weathering which were carried out by mechanical action, chemical decomposition, and organic action. Now, the weathered material or the weathered products are of two types. First one is called alluvium. Now, alluvium is the end product of weathering, and it's that part of the weathered product which lies over and above the parent rock. So it contains fragmentary material either after mechanical or chemical or organic weathering. Now again we have another term called diluvium. It is the end product of weathering, and the specialty of this product is that it has been moved to some distance after weathering. So usually in slopes they fall down the slope under gravity, and diluvium is found at the bottom of the hill. Now this is just an example of diluvium. Now both together, the diluvium and alluvium, is known as regolith. That is all weathered material, either alluvium or diluvium, that lies on the parent rock or near it is known as regolith. Now we will come to the products of weathering, and before we go into the products of weathering, first we have to understand what soil profile is. Now, in order to understand soil profile, we should understand what soil is. Now, as you know, minerals are the building blocks of stones or rock. The weathered product, which is either alluvium or diluvium, contains the minerals which are the basis of parent rocks. But when there is a chemical decomposition, there is a change in the chemical composition of the weathered particle or soil. Now, when we speak of soil, it's a mixture of all the weathered products. In short, if we say what is soil, they are the minerals or the mineral products formed from rocks due to weathering and erosion. So another aspect that we have to deal or we have to understand regarding soil formation is erosion, which follows weathering. Now when we put together you will understand what weathering is. The agents that will produce or that will create weathering, mainly, as I told you earlier, are lithosphere, atmosphere, and hydrosphere. Now, to be specific, the action of water, the action of wind, the influence of temperature changes, the influence of gravity, the chemical interactions of living organisms, pressure differences, all these help or all these create the breakdown of the parent material. Now, as such, all these together makes soil or results in the formation of soil. Now, the mixture of organic matter, minerals, gases, liquids, and organisms that support life in the earth's body of soil is called pedosphere. Now, as you know, there are functions of pedosphere as it serves a medium of growth for plants, as a means of water storage, supply, and purification, as a modifier of Earth's atmosphere, and it acts as a habitat for organisms. Now, all these functions modify soil and its properties. Now, when we understand soil formation, it is formed when organic matter has accumulated and the colloidal particles within the soil or within the organic matter are washed downward, leaving deposits of clay, humus, iron oxide, carbonate, and gypsum, producing a distinct layer called the B horizon. Now, regarding the horizon termed as B horizon, you will understand it better when we deal with soil profile, which follows. Before that, I would like to say that mixtures of sand, silt, clay, and humus, which once supported the biological and agricultural activity at the top or at a place, are moved from one level to another by water and animal activity. As a result, horizons or layers form in the soil profile. There is many layers are formed in the soil profile. Now, what is a profile? You might have dealing with drawings, engineering drawings, civil engineering drawings. So you might be familiar with section of a plan. Similarly, if you take a section of the earth, you get soil profile. The alteration and movement of materials within the soil causes the formation of distinct soil horizons. Now regarding the soil profile, almost we have 4 distinct layers for the soil profile, starting from top as zone A, which almost extends up to 3 meters. Then next comes zone B, which again extends up to 3 meters. Altogether, the bottom of zone B coming to be 6 meters from top. So beneath zone B, we have zone C, which again extends up to 3 meters. And below that, we have zone D, which extends extensively downwards. So altogether, we have 4 layers in the soil profile, that is zone A, zone B, zone C and zone D. Now as we explained or understood all through until now, the top layer is actually covered with vegetation, and hence the leaves and dead and decayed vegetation will cover the topsoil or the top portion or zone A. And since zone A is in direct contact with atmosphere, the gases, the moisture, water vapor are exposed to rain even, and weathering occurs there extensively due to mechanical, chemical and organic weathering, and hence in the zone A, in the topmost portion, we have completely weathered soil. And this portion may contain humus, which is organic acid produced due to decay of vegetation. And this acid also enhances weathering. Now comes zone B, that is just below zone A. Now below zone A we have zone B, which is a zone of mixed composition. Because as you know, it contains partly of soil and partly of weathered rock. And how does this soil reach zone B? It's through percolation of water, either by a running water or from rain or by any means. When water percolates, it carries a part of the top soil, and it reaches zone B. So zone B is a mixed composition, partly of soil and partly of weathered rock. Then beneath zone B, we have zone C, which is a soil-free zone. It is because, as you know, soil is weathered rock, and zone C is partly under the action of weathering because the contact with atmosphere is almost cut beneath zone B. So it is a soil-free zone, and it is partly under the attack of weathering, and the rocks are not completely disintegrated or decayed. So this is zone C, and last beneath zone C we have zone D, and because above zone D we have zone C, zone B and zone A, which completely cuts contact of zone D from the atmosphere, and also from contact with water or organic acids or weak acids due to percolation. Because of the depth of the zone D, we have no agents that are creating weathering at zone D, and hence we have intact rock or parent rock at zone D, which extends extensively downwards. We also know that the overlying part has been attacked by weathering and extend to almost 9 meters. That is the top layer. Zone A is 3 meters almost at an average depth of 3 meters. Zone B has an average depth of 3 meters. And zone C has an average depth of 3 meters. So altogether, zone D starts at an average depth of 9 meters beneath the soil. Now, if you think of foundations that you lay, almost we have 10 meters deep, we have the hard rock or parent rock. In a general understanding, dear students, now we'll be having a general understanding specifically on specific types of weathered products of rock. First one is sand. So, sand is a granular material composed of finely divided rock and mineral particles. It has various compositions, but generally, in civil engineering terms, it is defined by its grain size. Now, sand grains are smaller than gravel and coarser than silt. Now, usually the grain size of sand varies from 0.074 mm to 4.75 mm. To understand the formation of sand, we have to come back to the term weathering. Actually, it is a breaking down of rocks, soils, minerals, as well as wood and artificial materials also through contact with water, atmospheric gases, and biological organisms. Now, weathering occurs in situ, that is, at site or on site, or in and around the parent rock, or with little or no movement. Now you have to understand that erosion involves the transport of rocks and minerals by agents like water, ice, snow, wind, waves, and gravity. Now when rocks break down from weathering and gets eroded over thousands and even millions of years, they in the process get decomposed into silica, especially silica or quartz and feldspar. Often starting thousands of miles from the ocean, rocks slowly travel down rivers and streams, constantly breaking down along the way. Once they make it to the ocean, they further erode from the constant action of waves and tides. Now, for example, take the condition of India. We have the Everest at the north. Now, you might have learned in geography that from the high altitude of the north, we have rivers running down into the oceans and seas. Now, rivers originate, for example, Ganga. Ganga originates from Gangotri. Now, these rivers, which originate from the ice caps or from the melting of ice from the colder regions, travel down as rivers and streams and finally reach the ocean or sea. Now, during its travel, it carries the weathered rock, and further those rocks are broken down along the way. Now, when these weathered particles or weathered rock reaches the ocean, they are further under constant action of waves and tides. And finally, we get the product known as sand. The tan color of the most sand beaches is the result of the presence of iron oxide, which is a quartz which in the light brown color, and another is feldspar, which is brown in color. Sometimes we find black sand from eroded volcanic material like lava, basalt rocks, and other dark colored rocks and minerals typically found near volcanic activity or near areas of volcanic activity. Most common rock from which sand is formed is granite, where feldspar minerals dissolve, faster than quartz, causing the rock to break apart much faster than in calm settings. In general, if you think of sand, it is nothing other than SiO2. Next is clay. When we speak of clay, it's fine-grained material. It's very fine-grained. And they are fine-grained natural soil material containing clay minerals. Now they are formed by the prolonged chemical weathering of silicate-bearing rocks. They can also form locally from hydrothermal activity. Now hydrothermal activity includes temperature changes in the water. So usually hydrothermal activity occurs in the Earth's crust from sources of heat like volcanic activities that are going. Now when we come back to the formation of clay, they are formed by chemical weathering of silicate bearing rocks, and as you know, the chemical weathering is nothing but acid hydrolysis by especially weak carbonic acid. And this weak carbonic acid, which is formed from water and carbon dioxide, or water vapor and carbon dioxide, that is dissolution of carbon dioxide in rainwater, or else it can be created or released by plant roots. Now this acid breaks the bond between aluminum and oxygen, and it releases metal ions and silica. Clay minerals formed depend on the composition of the source rock and the climate. Now, usually clay is of two types, that is primary clay and secondary clay. Now primary clay is formed as a residual deposits in the soil and remain at the site of formation. Secondary clay is transported by water erosion, and hence it's termed as secondary. And it is deposited in a new sedimentary deposit. In general, clays and clay minerals are formed in soil horizon from continental and marine sediments, geothermal field, volcanic deposits, and weathering of rock formations from contact with air, water, or steam. Now, between 1.5 and 2/3 of the world's population in both traditional societies as well as developed countries still live or work in buildings made of clay, often baked into brick as an essential part of its load-bearing structure. Now, many building materials are being invented and innovated towards load-bearing structures. But still, there are buildings between 1/2 and 2/3 of the world's population that dwell in where clay is an important ingredient of the load bearing structure. Next, let us understand what laterite is. Now, laterite is of both soil and rock type, which is rich in iron and aluminium. It has a rusty red color because of the iron oxide content. It is formed in hot and wet tropical areas and are developed by intensive and prolonged weathering of the parent rock. Now, let me introduce a term known as laterization. So, tropical weathering or laterization is a prolonged process of chemical weathering which produces a wide variety in the thickness, grade, chemistry and or mineralogy of the resulting soils. Now, laterites are formed from the leaching of parent sedimentary rocks, especially sandstones, limestones, and other metamorphic rocks and igneous rocks. Now, the leaching is a process by which acid dissolves the host mineral lattice, followed by hydrolysis and precipitation of insoluble oxides and sulfates of iron, aluminium, and silica under high temperature conditions of a humid subtropical monsoon climate. In short, it is a chemical process where the mineral lattice or the mineral content of the rock is dissolved by the acid or especially weak carbonic acid, which is followed by a process of hydrolysis. And hydrolysis is a chemical reaction with water. And finally, it leads to the precipitation of the insoluble oxides and sulfates of iron, aluminium, and silica. That is, solidification. Due to the reaction, they are converted into oxides and sulfates of iron, aluminium, and silica under high temperature conditions. And these particles are insoluble and hence they precipitate out. And this happens in humid subtropical monsoon climate. Now, repetition of alternate wet and dry seasons is required for the formation of laterite. That is, during wet season, the rainwater percolates the rocks, which enhances leaching. And the resulting solution containing the leached ions is brought to the surface by capillary action during dry season. These ions form soluble salt compounds which dry on the surface and are washed away during the next season, and the cycle continues. Now, as you have heard about and understood about the soil profile, it has 4 horizons: A, B, C, and D. And the top layer is zone A, and just beneath it we have zone B, and just beneath it we have zone C, and finally we have zone D, which is the bedrock. Now, as I told you earlier, soil belongs to zone A, and in tropical areas where we have this humid monsoon climate, especially in the subtropical areas, we have this climate where we have alternate wet and dry conditions, especially Kerala, where there is monsoon season followed by dry season. The soil profile in this, especially the zone B, will contain laterite. So laterite is often located under the residual soil. Thank you.